Hello students, so welcome back to yet another session of chapter solid states which has already begun, and for the lectures which has been taken before, for them the link is given in the description box below. Just follow those lectures. So till now we have just completed the introductory part of solid state where we have classified the solids into amorphous and crystalline, and crystalline solids were further classified into four major categories, that is ionic, covalent, metallic and molecular solids. So please remember that that section of the chapter is quite theoretical and lots of one marker questions are made from that section. So please follow those lectures and then start seeing this lecture. So in today's class we are going to do the third part of the flow of the chapter, that is nothing but structure of solids. Correct? In structure of solids we are going to talk about everything at microscopic level, and of course I have already told you that we are going to three-dimensionally view all the structures. So please be very attentive in today's class. I am your host Manjot Singh, and let's begin with today's lecture. So to understand the structure of solids, it's very important that you understand the two major terms of structure of solids. Yes, if you don't understand these two terms, you cannot further understand what solids are made up of. So chaliye, let's uncurtain the two important terms, that is nothing but crystal and crystal lattice. Now understand this, but this is very important. Very thin line difference, very thin line difference between crystal and crystal lattice, and I'm going to show you all the things today in very beautiful pictures. So be very attentive. It is going to be a very interesting class. Now what is a crystal? Let's define that. A crystal is a solid in which atoms are arranged in some regular repetition pattern in all directions. Now if it's a regular repetition, you understand we are talking about crystalline solids only now. Correct? Alright. Now crystal means the actual arrangement of atoms. And how does it look? It looks something like this. So you see, all the atoms, all the particles over here, they are regularly arranged. You can see, you go in any direction of the solid, you get a regular repetitive pattern. You talk about this over here, there's green. You talk about this direction over here, there is green, blue. So there's a regular repetition pattern, right? So when these atoms are actually represented, it is known as a crystal. But this arrangement sometimes creates a lot of confusion when we want to do some calculations. So what we have done is, we have basically converted this crystal into a crystal lattice. And what is the crystal lattice? It is a three-dimensional arrangement of constituent particles in a three-dimensional space. Very important. See, it's just simply a conversion of crystal to crystal lattice like this. So you see, now instead of actually representing the atoms, we are just pinpointing that this point over here constitutes an particle, this point over here constitutes a particle, this point over here constitutes a particle. Now actual arrangement is, there's a whole sphere over here, there's a whole sphere over here, right? And yes, the particles are assumed to be spheres, Why they are assumed to be spheres? Because spherical calculations are the most easiest. So that is why it has been, standardized that the particles in the solid are considered to be spherical, assumed. So this is very important. Is that okay? Crystal and crystal lattice. Then we need to understand the characteristics of crystal lattice. What are the characteristics? The characteristics, first characteristic is that each point over here, see, I am highlighting this point over here, each point of the crystal lattice is known as lattice point, or it is also sometimes termed as lattice site. And each lattice site is depicting that there is a presence of particle over there. अब सर बार बार पार्टिकल पार्टिकल कर रहे हैं, तो ये पार्टिकल कौन कौन से हो सकते हैं भाई? ये पार्टिकल एटम्स हो सकते हैं, ये पार्टिकल मॉलिक्यूल्स हो सकते हैं, और ये पार्टिकल्स आयंस हो सकते हैं, जो कि हम क्रिस्टलाइन सॉलिड का क्लासिफिकेशन करके आए हैं. इज दैट क्लियर? सो very very important, the first characteristic is of the crystal lattices that every point in the crystal lattice is basically depicting the particle's presence. And if you just try to imagine this crystal lattice, there is a very very important term over here coming. See, I'm highlighting over here with a red color ink. This is the smallest 3D portion of this crystal lattice. You see, if you just take out this smallest 3D portion and repeat it in all 3 dimensions, you will get the whole crystal lattice. So this is the second characteristic over here, that in a crystal lattice there is the smallest 3D portion, which when repeated in 3 directions, in 3 dimensions, you get basically the whole crystal lattice. And this smallest unit of crystal lattice is known as unit cell. Yes, very very important. This is where your terms will start to flow and the confusions might start. Crystal, crystal lattice and a unit cell. Crystal and crystal lattice में एक thin line difference था. Crystal में actual atoms, crystal lattice में we depict those atoms with the points that are known as lattice sites or lattice points. And in that whole crystal lattice, the smallest 3D portion which is repeated to get the whole crystal lattice is known as unit cell. Very very important. So what is a unit cell? The most important portion of this chapter, the smallest portion, and mind it, very very important, smallest portion, not only smallest portion, it's the smallest 3D portion, 3-dimensional portion of a crystal lattice, which when repeated in different directions generates the entire lattice, is known as unit cell. And see this, very very important, this was the whole crystal lattice we just saw in the last slide. उसमें से smallest 3D repeating pattern जो है वो ये green color का जो highlight किया है, so that is basically known as unit cell, and these points over here are known as lattice points. I told you I'm going to give you all the beautiful pictures so that this chapter becomes very very easy for you. It's a 3-dimensional chapter. Please understand this. Now, a unit cell is basically characterized by 6 parameters. Yes, unit cell is characterized by 6 parameters. And what are those parameters? The parameters are 3 edges and interfacial angles. Yes, let's see that. 3 edges. 3 edges, that is nothing but this A, B and C. You get that? And 3 interfacial angles. The angles between the phases, right? The angle between B and C phase, alpha. The angle between A and C phase, beta. And the angle between A and B phase is gamma. So these 3 interfacial angles and the 3 edge lengths, basically edge lengths and 3 interfacial angles, these are basically responsible of characterizing unit cell. And who was the first person? Who was the first person to basically bring about these characteristics? His name was nothing but Auguste Bravais. Very very important scientist. Now, where did this story start from? Auguste Bravais in 1848 demonstrated that in a 3-dimensional system there are 14 possible lattices. एक 3-dimensional system में we can have a maximum of 14 lattices, and since he found it experimentally, that is why these lattices are known as bravais lattices. Correct? Very, very important. A bravais lattice is an infinite array of discrete points with identical environment. That's basically a crystal lattice definition. Correct? And out of these 14 possible lattices, he said that there are 7 basic unit cells, meaning 7 basic crystal systems. And how are these crystal systems produced? They are produced with the relation between A, B, C and alpha, beta, gamma. The 3 interfacial angles and the 3 edge lengths. इनके बीच में जब हम रिलेशंस निकालते हैं तो हमारे पास 7 बेसिक सिस्टम्स बनते हैं और उन 7 बेसिक सिस्टम में से हम 14 ब्रेवाइस लैटिसेस जो हैं वो डिराइव कर सकते हैं. And how are they derived? They are derived by symmetry. Now this symmetry looks a very small term, but it's a very, very huge term. But at this stage of 11th and 12th, you do not need to know in detail about symmetry. You do not need to know. So we are not going to go in detail of it. But yes, lattices are characterized by symmetry. Correct? अब A, B, C, अल्फा, बीटा, गामा, ये 6 पैरामीटर्स को रिलेट करते हुए हमारे पास क्या बनते हैं बच्चे? 7 बेसिक यूनिट सेल्स. तो it becomes a very important point over here that we first of all understand that how are unit cells characterized or classified. So unit cells are classified as 2, that is primitive unit cell, and very important, centered unit cell. So you see, a primitive unit cell is nothing but the unit cell in which the constituent particles, listen to this very carefully, the constituent particles are present only at the corners of the unit cell. So you see, only the corners are being occupied. And how many corners are there? This is very, very important. How many corners are there? There are basically 8 corners. There are basically 6 faces. Yeah, there are 6 faces. Imagine the room you are sitting in right now while you are watching this lecture. It's a cubicle room, right? So how many faces are there? The face, one face which is the fan face, that's first phase. One phase on which the bed is lying, that's the second phase. One phase on your left, the window face, that's basically your third phase. One phase on your right, that's basically your almirah wala phase jo hai, basically that's your fourth phase. One phase in the front where your 42-inch LED TV is lying, that's basically your fifth phase. And one phase, the resting phase on which you are right now lying down and seeing this lecture, right? So just try to imagine this. So these 6 phases, how many edges are there? There are 12 edges. I can make you count. 1, 2, 3, 4, right? Similarly 4 in the below, so 4 and 4, how many edges? 8. Yeah, so 1, 2, 3, 4, 5, 6, 7, 8. This is a 5, 6, 7, 8 and the 4 below, that is 12. So 12 edges, 6 faces and 8 corners. This is the characteristics of a unit cell. Correct? So primitive unit cell, when the atoms are present only at the corners. But the centered unit cell, which is actually a derivation of a primitive unit cell, it says the unit cell in which the constituent particles are present at the corners as well as at other lattice sites. What are the other lattice sites? It could be a face center, it could be a body center, it could be a edge center. Let me try to explain you. Face center मतलब किसी भी फेस के सेंटर में अगर आपके पास क्या है, पार्टिकल है, तो उसको हम बोलेंगे फेस सेंटर यूनिट सेल. So when all the 6 phases of a unit cell have the atoms on it, as well as the corner atoms are also there, it is derived from a primitive unit cell. So unit cell in which the constituent particles are present at the corners as well as the other lattice sites. So when they are present on the 6 phases, then it is known as a face center unit cell. Similarly, when they are present at the body center, that's basically the center of the body, that is known as a body center. And similarly, when they are present at the edge center, they are known as edge center unit cells. Any edge center, if it is present, it is known as edge center unit cell. Perfectly okay. So basically your unit cells or crystal systems are classified into 2 parts, primitive and centered. Primitive are nothing but when the atoms or the constituent particles are present only at the corner atoms, only at the corners of a unit cell. Whereas centered, wherein the other lattice sites are also occupied in addition to corner atoms. That's very important. So basically these are derived. Mind that. Is that clear? Alright. Then now since we are aware that we have some fundamental, not units basically, bache, we have some fundamental unit cells. Not fundamental units, we have fundamental unit cells. That's 7 crystal system. So what are those 7 crystal system? Let's see that. Those 7 crystal systems are nothing but these. Now understand, try to understand this. I already told you these 7 crystal systems are basically derived by relation between A, B and C and alpha, beta and gamma. Correct? Okay. There's been a misprint over here. Wherever there is a square, it is a beta. Okay? Wherever there is a square, it's a beta. So in cubic unit cells, you will see that A is equals to B is equals to C, that is all the edge lengths are equal, and alpha is equals to beta is equals to gamma, that is 90 degree. All the interfacial angles are 90. Cubic unit cell, पता चलता है हमको क्यूब क्या होता है, हमें पता है. Then tetragonal is when A is equals to B. So basically you hold the cube into your hand and pull it along the length, correct, along the height basically. So you get a tetragonal unit cell where A is equals to B but not equals to C. Alpha beta gamma अभी भी 90 ही है, ये ध्यान देना मेरे बच्चे, अल्फा बीटा गामा अभी भी 90 है. Similarly, we go to orthorhombic. Orthorhombic में you pull and you stretch also. So A becomes not equals to B, not equals to C, but alpha is equals to beta is equals to gamma, that is 90 degree. Perfect है. And obviously साथ साथ में examples चल रहे हैं. ये table particularly you have to learn only. Yes, very very important. बहुत इंपॉर्टेंटली ये पूछा जाता है, डायरेक्टली वो पूछता है कि भाई क्यूबिक यूनिट सेल का एग्जाम्पल दो, राइट? या फिर वो बोलेगा अ यूनिट सेल इन विच ए इज इक्वल्स टू बी इज इक्वल्स टू सी एंड अल्फा इज इक्वल्स टू बीटा इज इक्वल्स टू गामा इज इक्वल्स टू 90 डिग्री, विच टाइप ऑफ यूनिट सेल इज डिपिक्टेड बाय दिस? अच्छा, कभी कभी वो बहुत स्मार्ट क्वेश्चन भी करता है, जस्ट एनालॉजी क्रिएट कर देता है. अ रूबिक्स क्यूब is which type of unit cell? So it's a cubic type. A matchbox is which type of unit cell? Where A is not equals to B is not equals to C, but alpha, beta, gamma are 90 in matchstick. So it's a orthorhombic unit cell. Getting the point? So this is how questions can be twisted from this table. General आपके अराउंड जो चीज़ें हैं उसको लेके वो आपसे क्वेश्चन करने की कोशिश कर सकता है. And mind it, the order of stability of these unit cells are the one which is given in the table right now. So the highest stability order is cubic. Yes, most of the elements they want to get into cubic unit cell. Correct? Then comes tetragonal, then orthorhombic, and then rhombohedral. rhombohedral में ए बी सी तो इक्वल है, बट अल्फा बीटा जो है वो 90 है, बट गामा अल्फा इज इक्वल्स टू बीटा इज इक्वल्स टू गामा, बट दे आर नॉट इक्वल्स टू 90. ध्यान से देखो, क्यूबिक और रोम्बोहेड्रल में थोड़ा सा ही फर्क है. वहां भी एंगल्स इक्वल हैं, यहां भी एंगल्स इक्वल हैं, वहां भी साइड्स इक्वल हैं, यहां भी साइड्स इक्वल है, बस वहां एंगल्स 90 हो जाते हैं और यहां एंगल्स 90 नहीं होते हैं. इज दैट क्लियर? परफेक्टली ओके. देन वी कम हेक्सागोनल. हेक्सागोनल इज व्हेन ए इज इक्वल्स टू बी नॉट इक्वल्स टू सी. हेक्सागोन देखा है ना हमने, एंड आई एम गोइंग टू शो यू, आई टोल्ड यू आई एम गोइंग टू show you all the pictures possible for this chapter. So hexagonal हमने देखा हुआ है, बस वहाँ पर अल्फा बीटा 90 है और गामा 120 हो जाएगा. मोनोक्लिनिक, मोनोक्लिनिक में साइड्स अनइक्वल, अल्फा और गामा 90 है बट बीटा नॉट 90. एंड ट्राइक्लिनिक इज द मोस्ट अनस्टेबल फॉर्म, जहाँ साइड्स भी इक्वल नहीं है और एंगल्स भी इक्वल नहीं है. All this is a detailed study of symmetry. Mind it. This you are going to do in your higher classes if you go into some engineering field. So there you are going to learn symmetry, and from there you are going to understand all this. But right away, we do not need to get into symmetries, and we just have to see this table, learn this table, the relation between the crystal system and axial distances and axial angles. Now, let's see how these 7 crystal systems look like. These look like this. See, this is basically the parameters. This diagram is depicting the parameters alpha, beta, gamma, A, B, C. And then you have cubic, tetragonal, orthorhombic, monoclinic, hexagonal, rhombohedral and triclinic. Very, very important. This is how your 7 crystal systems look like. And from this 7 crystal system, there are 14 bravais lattices which are derived. And once again, a very, very important table is coming up on your screen, which is going to be a very, very important table. Yeah, so please mind it. Cubic के अंदर हमारे पास 3 तरह के derivations possible हैं. That is primitive. Primitive मतलब fundamental, बॉडी सेंटर एंड फेस सेंटर. जिसमें बॉडी सेंटर में आपको बता चुका हूं कि भाई जब कॉर्नर्स प्लस बॉडी के सेंटर में आपके पास क्या हो, एटम हो. फेस सेंटर जब कॉर्नर्स प्लस ऑल द 6 फेसेस दे हैव व्हाट बच्चे, ऑल द 6 फेसेस दे हैव द एटम्स और द पार्टिकल्स. सिमिलरली टेट्रागोनल में डेरिवेशन आएगा, प्रिमिटिव तो रहेगा ही रहेगा, फंडामेंटल है, और उसके साथ साथ सिर्फ एक ही डेरिवेशन, दैट इज फेस सेंटर. There is no body center over here and there is no end center over here. Similarly, when you go to orthorhombic, orthorhombic में आपके पास सारे derivations मिलेंगे. That is primitive, body center, face center and end center. End center का मतलब क्या होता है? जब 6 faces नहीं, not all 6 faces, but 2 opposite faces, they have the particles in them. Corners तो है ही, उसके साथ साथ 2 opposite faces. It might be the one which is shown in the figure, or it might be one something like this here and here. Then उस टाइम पे यहाँ पर नहीं होगा. So this system becomes very, very important because all the 4 possibilities are present, and this is what the question is asked sometimes. आपको ये पूरा टेबल याद नहीं करना है. पिछला जो टेबल करवाया है वो तो पूरा अच्छे से करना है, बट ये जो अभी करवा रहा हूँ ये पूरा नहीं करना है. उसमें आपको एक तो क्यूबिक के डेरिवेशंस याद रखने हैं, दूसरा ऑर्थोरॉम्बिक, बिकॉज ऑर्थोरॉम्बिक में सारे पॉसिबल यूनिट सेल्स बन सकते हैं, ब्रेवाइस लेटाइसेस बन सकते हैं. और इसके अलावा कमिंग ऑन द नेक्स्ट पेज यू हैव टू रिमेंबर द ट्राइक्लिनिक वन. क्यों? क्योंकि इसके अंदर यू हैव ऑल द साइड्स एंड ऑल द एंगल्स अनइक्वल. So you see the derivations, 14 bravais lattices. We can see 1, 2, 3, 4, 5. You have 6, 7, 8, 9, 10, 11, 12, 13 and 14. 14 bravais lattices are possible, in which 7 of them are the fundamentals one. We can count the fundamentals one. 1, 2, 3 and then you have 4, 5, 6, 7. Right? You have these 7 fundamentals, and apart from that 7 other derivations from those fundamental or primitive cubic unit cells. So please, very important, this table which have been shown today, they are very important for you, and please mind it that the fundamental crystal system table is very important. The relation between the edge lengths and the interfacial angles is going to be of utmost important. वहाँ से direct questions, 1 marker, multiple choice questions उठते हैं in your competitive as well as in your board examinations. So before we start with the next lecture, just get acquainted with these unit cells and wait for my next lecture to come. Till then, please take care of yourself. Bye bye.